Hello? All right, perfect. Good afternoon. My name is Nasser Noei. Welcome to our presentation of a programmable network. I work for Delta Network here in Fremont. I'm Director of Software. Today, we are going to present along with Roger and Bo, my colleagues. Roger is going to I'm going to do the introduction to the company. Roger would present the programmable switch, and Bo would show you the programmable platform. And we'll show you an end-to-end programmable platform. Everything you see here, all are open software. There's nothing that we are using that is proprietary to Delta on some of our platforms. It's not on all of our platforms, but whatever we present today is all available. If you want to get it and try it, you're welcome to. So let me get started. So first, a bit of introduction to Delta and who we are. Delta has been around since 1971. We started as power and cooling, and then as of 2000s, we are in the switching. We make a lot of white box switches from gigi to 400 gig. You can come see us at our booth. We have all of them at display, all the solutions we have for networking. Our headquarters in Taiwan, but we have sites all across the world, in Europe, Asia, and Americas. So why programmability is important? I'm taking a slide from Nick McEwen on what happens today. So if a customer comes to a telco or switching company today and they ask for a feature, they first have to go discuss that feature with their product line and development. Then they have to develop the software necessary for that feature. They have to modify the ASIC for that feature, then turn around, come back. Years have passed. And that is where one of the reasons that people want programmability. They don't want to wait for a year for a small feature. Where do white boxes and platforms fit? This is a view from Chris at AT&T Labs. The key things to point out in this slide is they want hardware to be swappable. They don't want proprietary hardware anymore. They want the software to be standard. And they want programmability on top of that. And that's what we offer to our customers. Oh, went too far. Sorry, Roger. I jumped into your slides. So let me go back. So with that introduction, I'm going to get the interesting part started and hand it to Roger to do the programmable switch.
Thank you, Nasser. So in the next few minutes, I'm going to demonstrate Delta Network's white box switches loaded with Cumulus Linux as data center. In addition, I will also demonstrate Delta Network's white box switch acting as a data center interconnect. So with that, the demonstration for the data center interconnect will show the applications. I enable the segment routing. The network controller will program the switch. And only then that the communication between the data centers get established. So this is a topology that I have for the demo. As you can see, I have two data centers, DC1 and DC2. Both the data centers comprise of data networks white box switches. The DC1 and DC2 are loaded with BGP. And both of them don't communicate until the middle device, which is the DCI. is programmed by the ONOS controller. The ONOS controller will program the switch through an application that will enable PC segment routing. You will see in a moment that the data flows will be established on this switch. And then the communication from DC1 to DC2 will be established. So in the ONOS controller, you will see the UI will be like this. The spine of DC1 and the spine of DC2 will look at the host of the DCI. So let's jump into the demo. So as you can see right here, this is the lift number 1 of the data center 1. This is the lift number 2 for data center 1. This is the spine of data center 1. You have the spine of the data center 2, lift 1 of DC2, you have the lift 2 of DC2, and this is the DCI box. And right here we have the ONOS controller. It's kind of slow. There you go. So initially the switches in DC1 it sees the neighboring devices. All of them are in 10.100 address. Oops, sorry about that. It went away. Hold on. Okay, so and then on the other side, DC2 have the 10.200 IP addresses. So right now in this data center, it can talk to its neighbors. And then this other one can talk to its neighbors as well. There you go. Now let's go ahead and start the OFDPA on the DCI box. And while that is starting, let's go to the ONOS controller. So in a moment, you will see the topology pop up. Connection refused. Happened to the Give 1 second here. Okay, let's do this. Let's get back to here. Something went wrong. It doesn't. Somehow it's not connecting. Okay, I don't know right now what's going on, but it's getting connection refused.
So let me then have Bo come up.
Yeah.
Sorry guys, the OFDPA and ONOS controller is failing to connect. Instead of having you sit here watch Roger debug, let me have Bo come up and show you the programmable platform and do REST control of the platform elements. And in the meantime, we'll try to figure this out.
Yeah.
Sorry about that. So Bo, yeah. So because they're independent of one another. One is controlling the switching infrastructure with OFDPA. What Bo is presenting is actually REST and Python control of the platform, which is the LEDs, fans, and the rest of the elements. All right.
Hello, my name is Bo. I'm the principal engineer of Delta Networks. Today I'm going to present the Delta White Box Platform API. So why the Platform API is so important and well it is used. So let's look at the SDN. In the SDN, so the network has been disaggregated into 3 layers with the network devices at the bottom and the controller or network OS in the middle, and then network application on the top. So with the network OS or the controller in the middle, so northbound, they provide the overall view of the network. So the network application can rely on this information to make the key decisions on how to implement the network policy. And southbound, So the controller or NOS need to use the standard protocol, for example, OpenFlow, to talk to the ASIC, modify the flow table, and control the packet forwarding. On the other hand, it also needs to control the peripherals, like those fan, LED, those environmental. Today, the hardware on those environmental varies, like LED fan, varies from platform to platform, differs from vendor to vendor. There's no standard, no unified way to access them. At Delta, in order to get our customer on board faster and cut down their development time, we are working on a software library which can provide one set of API across different platforms to control the environmental, like a read or write to those LED fan or port. So this is the platform API. So let's look at take a deep insight into the platform API. So as you can see in this diagram, the platform API contains like 3 key components. We have the platform API described abstract interface, which is common and generic across multiple Delta platforms. And we have the platform driver who implement those API, which the implementation-wise is very lightweight. We are using Python. And then we have REST API server to expose those platform API to the remote client. And additionally, we have the Swagger page to do the online documentation for REST API. So with this API, we can see customer or user can create a platform manager, invoke the platform API locally to control monitor the environmental, LED fan, port, and also SDN controller can invoke the REST API to control the environmental as well. Furthermore, the customer can even develop their own remote in-service diagnostic service using our API. So the control can be either on the box or off the box. Here is the snapshot of our Delta Platform REST API. This is the Swagger page. I'm going to explain in detail in the demo following. Okay. Oh, sorry, this is too big. Okay, this is the Delta Swagger page of Delta Platform API. We can see right now the API endpoint is pointing to the API server running on one of our AG7648. So it's 10.62.2.56 at port 5000. And right now, the method is HTTP. And we can see there are a group of API, a set of API for the fan. And also, scroll down, we can see there is a set of API for LED. This is for proof of concept purpose. So we put a fan LED here. And we can use the HTTP GET to list all the fan in the system or get the capability of the individual fan or get description of individual fan. Also, we can get the fans at RPM. Also, we can use HTTP post method to change the RPM. So now, let me show you how to use the API to control the fan. Also, similar operation can be done on the LED as well. So this is the Swagger, so you can see the documentation from here. And when I click and also you can use this portal to play with our API before your integration. So for example, right now I use the get command to list all the fans in the system. So now you can see there are 6 fans here. And now I want to get, for example, the number 2, the fan number 2's description. So I give the fan ID and execute this API. And you can see the request has been sent to this URL. And the description says the fan 2, number 2 is chassis fan. And then also I can get this fan 2 capability. So the fan 2 says the minimum RPM is 0 and the maximum is 19,000. Then I want to change the fan speed. First of all, I want to get the fan speed, fan RPM first. So we have the, right now, the speed right now you can see is the around 15,000. Now I'm going to use the post command to change the fan RPM. So I want to reduce the fan speed to, for example, 10K. So the response says it succeeds, and then we do the get to verify the speed to see whether it has been reduced or not. So we execute again. So now you see the fan speed has been reduced from 15,000 to 10K. So basically, this is I show you the idea how to use the REST API, underlines the platform API to control the environmental running on our Delta platforms. This is the end of my demo, and Nasser, yeah.
Thank you very much. Sorry about the OFDPA. The good news is OFDPA is common to all platforms. The way it runs with the controller is the same. The unique part that we wanted to present is the platform API. You can write Python code with curl commands. You can use the REST API to manage your box remotely. You can diagnose. A lot of our customers today are asking us, how do I remotely diagnose whether a fan is running? So for them, this is an ideal solution. The northbound of our API are Python, REST, and standard. Southbound are hidden from you, and you don't need to worry about it because they're all I2C calls. So with this, now the only thing that's missing in your programmability is the ability to program the optics. The rest of it with OFDPA platform API, the only piece remaining would be your optics, which need to be programmable. So with that, I open to questions. I'll ask Roger and Bo to come up. We have 2 minutes. We can take a few quick questions and then invite you to our booth for any longer questions. Any questions? I saw nobody sitting in front, so I guessed there are a lot of people who are afraid that if either I'm going to ask questions or I'm going to ask for them to ask questions. You have a question? Yes, go ahead. Yes.
So you mentioned the programming the optics. So
yes.
What are, if a customer is using a Delta switch,
right.
What are the optics?
So there are a number of optics today that offer, I'm not an optics expert, I'm a software guy, but there are a number of optics and there are a number of standards that are coming out to allow you to be able to read optics capabilities, turn on and off the optics, and increase the laser capabilities. I'm not an expert in that. That's why I excluded it from our presentation. But with that, you would have literally an end-to-end automation if you have optics that are programmable. So we come right out of lunch. So I know it's not the best time to do the presentation. Unfortunately, our OFDPA refused to connect as well. So, but you know, that's common to all platforms, nothing unique. Go ahead, please. No, so we actually have all of the northbound as platform independent. We have checked it into our Git repository, and they are common. Southbound vary from platform to platform. Those are because they have different connectivity to I2C. So southbound, you don't need to worry about, but the northbound are all platform independent. And they all are available via programming for Python and REST.
Rest. Any more question?
All right, thank you very much.
Thank
Our
you.
There's one
time's
question
over.
over here.
Oh, but
No.
our time's up.
Thank you.
Yes.
You can come to our booth then.
Yeah, please come visit us at our booth. We'll be more than happy to help. Thank you very much. Thanks for attending.